So hello my dear lovely student, curious student, how are you all? Hope you all are doing well, you all are fit, healthy and fine. So welcome to your favorite channel Deeksha Vedantu, where we are providing complete academic solution to you all for last 27 years. We believe in quality education, we are above to spice and glamour. We believe only in quality education, and that is the reason why we are producing thousands of toppers every year. And you are also in queue, you might be the next topper. Okay, so well, you might be thinking who is the new face here on this channel. So let me introduce myself first. Well, my name is Mohammad Murtaza, a bit challenging to pronounce. Yeah, you can call me Murtaza sir, Murtaza, and I'm going to teach you maths from today. And get ready to fall in love with maths, because we are going to make the maths very easy, very comfortable for you. So in today's session in maths, we are going to talk about previous year question of real numbers. So get ready to fall in love with maths, and I'm going to teach you maths, and I'm going to make the maths very fun-filled for you all. So maths is not challenging. You must be knowing the basic concept, clarity, theorem and all. And then you have to make your calculation very faster and smooth and very accurate. And that is the only method by which you can score good marks in mathematics. So you need to be very focused, very determined in mathematics, and try to follow us. And we are here to solve your query and your problem. So no need to worry in maths. Whatever your query, problem, we are going to resolve your query and your problem and your difficulties at all. And you might be feeling very confident after a few days. So without wasting a moment, we are going to start a very important session today, and we are going to solve few previous year question of real numbers. In real numbers, students feel, but real number is very interesting chapter, I think, because a real number demands from you to know the basic theorem and to know the basic concept, and that is we are going to clarify through the previous year question, to do previous year question. So dear student, I am requesting you all, please watch this video till the end, and this session is going to be very beneficial for you all. I am requesting you everyone. Okay, so without wasting moment, let's begin, let's start. So the first question here is, the greatest number which divides 70 and 125, leaving remainders 5 and 8 respectively is. So the question is asking what will be that number which is dividing 70 and dividing 125, and the remainder on dividing from that number to 70, the remainder is 5 coming, and on dividing from that number to 125, the remainder 8 is coming here. See, I am giving a trick here. If you are dividing these two numbers from any number which is unknown to us till now, so what we can do here, the trick is what? If you are dividing these two numbers, it implies that that number will be smaller to these two numbers. So this is clear that if we are dividing these two numbers from any number, so that number will be smaller from these two numbers. And here, on dividing from that number, the remainder is 5 and 8 respectively. So if the number is smaller from these two numbers, then it is clear that that number will come by doing the HCF of these two numbers. That is the trick. If you are dividing any two number, any three number, from any number that is common, means that number is the factor of these two numbers. So it indicates that you have to find out the HCF of these two numbers. But here the remainder 5 and 8 is coming here. So what we need to do here, we need to subtract the remainder first. 70 minus 5, that will be 65. And here 125 minus 8, that will be 117. So basically these two numbers are there, and these two numbers are dividing from by any number which is unknown to us. We have to calculate that number. So indirectly here, what we have to find, we have to find the HCF between these two numbers. The HCF between two numbers, because these two numbers are dividing by any other number, right? So how we can find the HCF? HCF means, you all know HCF, highest common factor. So HCF by doing prime factorization method, 65 can be written as here 5 into 13, right? And 117 can be written as here 3 square into 9, 3 square into 13 here. So look, which number is common to both of us? Which number is common? So 13, we can see here 13 is common to these two numbers, 65 and 170. So the HCF will be 13. So 13 is that number by which these two numbers are dividing and the remainders are coming as 5 and 8. We can prove it indirectly. Yeah, we can prove it. Let's say divide by 13. Divide by 13 to this number 70 here. Which number is coming as remainder here? 5, and correct. Let's again divide this number by 13 and prove it. So 13 divided by 125, what you will get? 13, 9 job 117, and the remainder is here 8. And look at the remainder 8 is here. So this is the way how we can solve this type of question. Okay, so this question was already asked in the year 2025. So such question generally asked in board examination. So you have to be very cautious, very ready for these kind of question. Hope you have understood this question. Okay, so move to next question here. The next question is based on assertion and reason. So look out the assertion. What assertion is saying here? For any two prime numbers P and Q, their HCF is 1. Yeah, absolutely correct. For any two prime numbers, the HCF always be 1, and LCM is P plus Q. This is a bit confusing here. The LCM is P plus Q. Okay, and the reason is for any two natural numbers, HCF cross LCM is equals to product of that number, which is absolutely correct. So let's talk about assertion first. What assertion is saying here? So for any two prime numbers, so let's say an example. So let's say an example here. Let's say two prime numbers are here. I'm taking here two prime numbers, 7 and 11. Let's say there are two prime numbers. Why two prime numbers? Because the factor of 7 is 1 and 7 itself, right? And the factor for 11 is 1 and 11 itself. And we know the definition of prime number, the number which are having factor itself and 1 is called prime number. So 7 and 11 both are prime numbers because their factor is 1. Their factor is, because their factor is 1 and 7, and here the factor of 11 is 1 and 11, right? So these two are the prime numbers. So if these two are prime numbers, so what will be the highest common factor? Which number is common in both? Right? Which number is common in both? So we can see here the 1 is common in both. So the HCF will be 1. So it is clear that if two prime numbers are there, so the HCF will always be 1. The HCF will always be 1. And if two prime numbers are there, the HCF is 1. And let's talk about LCM. What will be the LCM of these two numbers? So if I talk about LCM of these two numbers, how we can find? LCM is the least common multiple. How we can find? Let's 7 here. So what will be the multiple of 7? We can write 1 into 7 here. Right? 1 into 7. And for 11, we can write 1 into 11 here. Yeah, we can write 1 into 11 here. So what you are getting here? What you are getting here? What will be the LCM? The LCM will be 7 into 11, and the LCM will be 77. Right? The product of two numbers, product of two numbers will always equal to the product of their LCM and HCF. This is proved. So if I talk about these two numbers that I already took as an example, so the product of two numbers 7 into 11, and look what is the LCM here, 77, and look what is the HCF here. HCF is 1 here, right? So the HCF is 1. So 11 7 77, and 77 into 1, that will be hence proved. Means the LCM of any two prime number is the product of is the product of those numbers. Like if I've taken the two prime numbers like 7 and 11, so 7 and 11 both are prime numbers. So it is clear that if two numbers are prime, their HCF will be 1. It is clear, it is sure. Okay, and if two prime numbers are there, their HCF will be 1. And what will be their LCM? Their LCM will be always the product of these two numbers. If I am taking here 5 and 2, 5 and 2, both are prime numbers. And if I am asking you, what will be the HCF of these two numbers? So what will be the HCF is these two numbers? So it is clear that 5 and 2 both are prime numbers. So their HCF will be 1. Yeah, their HCF will be 1. And if I talk about what will be the LCM, as we know these two numbers are prime numbers, 5 and 2, because their factor are 1 and themselves, right? So the LCM will be 10, the product of these two numbers. So please keep it in mind, if there are two prime numbers, their product always will be equal to the LCM, and the HCF will be 1. So here, look at the assertion for any two prime numbers, P and Q prime numbers. Underline it, prime numbers. Then it is confirmed that the HCF will be 1. This is correct. This is absolutely correct. But look what they are saying, the LCM will be addition of these two numbers, P and Q. No. If P and Q are prime numbers, then their LCM will be the product of those. Yes, product of P and Q, but here they are writing the addition of P and Q. So assertion is absolutely false, wrong. And look at this. For any two natural number, HCF and LCM are equal to product of number. Yes, this is correct. Of course, this is correct. So reason is clarifying the assertion here, because assertion is based on reason here. Reason is absolutely correct. So we can go through option number. Which option number? Look, both assertion A and reason are true. No. Both assertion and reason are true. No. So assertion is false, but the reason is true. Assertion is false, but the reason is true. Assertion is false, but the reason is true. Yes. Is it clear? Hope you understood. For any two prime numbers, what the essence coming is from this question, what you understood from this question, the thing that you can understand by this question is, for any prime number, for any two prime numbers, the HCF always will be 1. And the LCM will be the product of those numbers that we are taking, right? Okay, come to next question here. This is the important question, I can say. This is a bit challenging for you, because this question demand your level of understanding. Hopefully you can do this question comfortably after explaining. And let's solve this question. Two numbers are in the ratio 4:5, okay, and their HCF is 11. Very good. Find the LCM of these numbers. See, I am giving you a trick here. For this type of question, I am giving you a trick here. What trick that we can use in this question here? See, you must be knowing that HCF is called highest common factor. Highest common factor implies the number which can divide the numbers. Like if I'm giving you one example here, like I'm taking here 8 and I'm taking here 12, and I'm asking you what will be the HCF of these two numbers. What will be the HCF of 8 and 12? So I'm asking you, okay, what will be that number which will divide both these two numbers? What will be that number which can divide these two? Common factor. So what will be the factors of 8? 1 can divide, 2 can divide, 4 can divide, and 8 itself can divide. And 8 itself can divide 8. And if I talk about which numbers can divide 12 here, 1 can divide, 2 can divide, 6 can divide, before 6 3 can also be divided, so no issues. Okay, and 4 can also divide, and 12 can also divide. Is there any other number which can divide 12? No. 1, 2, 3, 4, 6 and 12, right? So if I ask you, which number is common in these two? Common, which is dividing both. So we can see here 4 are common. 4 are common. Is there any other number? Is there any other number? Yeah, we can say 2 is also here. 1 is also here. But what HCF is saying? HCF is highest common factor. You cannot ignore the word highest here. Highest common factor. So which number is common and highest? So we can say 4. 4. So the HCF of 8 and 12 is 4. Simply. HCF is nothing. HCF is highest common factor. The number which can divide both the numbers. Simple. Nothing to worry. No need to get, confused. You must know the term. You must know the term. What the term is exactly saying. Highest common factor. And I am telling you one more thing. HCF always be less than the numbers. It can be equal or less than the numbers. If I am taking here 8 and 12, I am taking here 8 and 12. So what is the HCF? HCF is 4. Yeah, HCF generally comes smaller than the number. And if I talk about LCM, least common multiple or lowest common multiple, the LCM always comes greater from that numbers. HCF found smaller and LCM comes greater. Keep it in mind. Please keep it in mind, guys. Okay. So look what the question is saying. Two numbers are in the ratio 4:5 and their HCF is 11. Means 11 is that number that is dividing any two number which are in the ratio 4:5. I don't know the number. The ratio is given. But I'm not sure what exactly is that number. The ratio is given here. Okay, so 11 is the highest common factor. It implies that 11 is dividing the number whose ratio is given in the term of 4:5. If I told you earlier like 4 is the HCF of these two numbers, means 4 is dividing 8 and 4 is dividing 12 here. Simple. So if in this question HCF is 11, means HCF is 11 means 11 is dividing these two numbers. I am not sure what is exactly that number is. The ratio is given here. So we can conclude that if the ratio is given here, so what will be the number? If HCF is given, if HCF given is 11 and the numbers are in the ratio 4:5. I'm not sure what exactly that number, but the ratio is given here. And these two numbers, this number and this number, both the numbers is dividing by 11 because 11 is as given as HCF, highest common factor. So that number will be, so the numbers will be what? 11, 4, ratio is given. 11, 4 ja 44 and 11, 5 ja 55. Yes, both the numbers will be 45 by 55 because these two numbers are dividing by 11 because 11 is given as highest common factor. So it implies that 11 is dividing both the numbers and the ratio is coming as 4/5. Right. Okay, so we have already found out the number is 44 and 55. Right. Find the LCM of these two numbers. We have the theorem, the relationship between HCF and LCM. The product of LCM and HCF of any number is equal to the product of those numbers. Product of the numbers. Okay, so this is the theorem. This is the relationship between HCF and LCM. So by using this relationship, we can find out the result. LCM is, we have to find the LCM here. So LCM, HCF is already given, that is 11 here. and product of the numbers, we have already find the first number and second number here. So we can write 44 and 55 by calculating these. 44 and 55 divided by 11. So we can divide by 5. So the LCM will be 5 for 22, 5 for 220 is the answer. 220 is the answer. So the LCM of this question is 220. Hope you understood. Hope you have understood. Hope there is no any problem. If you are feeling, still you feeling any kind of difficulty, any problem, you can put your feedback or whatever you are facing any kind of problem, you can put in comment section. We will surely look into it, okay? And we will provide some any other, solution to you. Hope you understood this question. Okay, so highest common factor means the number which divides comfortably to those numbers we are talking about, right? Okay. Now come to the next question here. The next question is the smallest irrational number by which under root 20 should be multiplied so as to get a rational number should be multiplied by. Okay, to get a rational number. So rational, irrational, you have already talked about rational, irrational, and after this session, after this video, I am going to upload a new video for you all, one short session of real number. In that video, I am going to elaborate, explain in easy words, complete chapter in one session. So hope you will go through that video and that will be very profitable for you all. So let's talk about here the question, the smallest irrational number by which under root 20 should be multiplied so as to get a rational number. Hopefully you understood, you know the rational and irrational number. So let's solve this question, how we can solve this question. So there is under root here, under root 20. Okay, so under root 20 can be factorized as 2 into 2 into 5, right? 2 into 2 into 5. Okay, so under root 2 there is a pair of 2, so we can take out 2 and under root 5. If you observe this format here, so 2 and there is product of root 5. So we know root 5 is an irrational number. 2 is separately rational number, but under root 5 is an irrational number. So this whole family is still an irrational number. And that is the question asking ki by which smallest irrational number this format should be multiplied so that the result comes as rational number. So we have to eliminate the root term here. We have to remove the root here. So how we can remove root here? If under root 5 is already here, so what should we multiply to under root 5? Again under root 5. By multiply under root 5, that there will be a pair of root 5 inside the root. So there will be pair of, that will be 5 square. So what will be the result? Simple 5, and 5 into 2, that will be 10, and 10 is a rational number. So what we can multiply here? We can multiply this family by root 5. And by multiplying root 5, the result will be 2 into 5, and the result will be, and 10 can be also written as 10 by 1. And this is the format of rational number. Rational number, because the rational, what is the definition, basic definition of rational number? The number which can be represented in the form of P by Q, right? Where Q should not be equal to 0, where the number can be represented by P by Q and Q not should be equal to 0. This is the format of rational number. So 10 can be written as, 10 can be written as rational number, 10 by 1, that will be rational number. So what we are multiplying here? We are multiplying by root 5. So which option will be correct? Option number D will be correct. Option number D will be correct. By multiplying under root 5 to this number, the result will be a rational number. Hope you understood. Hope you understood, guys. Okay, so come to the next question here. The next question is a pair of irrational numbers whose product is a rational number is. Okay, so there are some pairs are given here. There are 4 options. The first pair is under root 16 and under root 4. The second pair is root 5 and root 2. The third pair is root 3 and root 27. And the fourth pair is root 36 and root 2. We have to choose, we have to find out the correct option here. And the question is saying a pair of irrational number, a pair of irrational numbers whose product is a rational number. Okay, so the pair should be irrational number because the question is saying a pair of irrational. So we have to find out which pair is exactly irrational format of. Which pair is exactly of irrational format. So let's talk about first pair here. Okay, so the first pair is under root 16. So under root 16 can be written as 4 and the under root 4 can be written as 2. Oh, and 4 can also be written as 4 by 1. 2 can also be written as 2 by 1. 2 by 1 and 4 by 1, that is the rational number. Yeah, this is the format of P by Q here. And 2 by 1, that is also the format of rational number. The number which can be easily written in the form of P by Q, where the Q should not be equal to 0 because we are writing here 1. So 4 by 1 and 2 by 1, both are rational number. And they are saying a pair of irrational number. So this option will not be the answer, right? Okay, please come on option number 2. So the option number 2, this was the option number A, and now we are going to talk about option number B. Option number B is under root 5. Yeah, under root 5 is perfectly irrational number. This is irrational number. And under root 2, and under root 2, this is also an irrational number, right? And if I apply the product of these two numbers, if I do the product of these two, under root 5 and under root 2, what the result is coming? Under root 10. And 10 is not a perfect square. So we cannot take out 10 outside of the root. Yeah, I cannot, because 10 is not a perfect square number. So under root it still is an irrational number. So the result is not coming as a rational number. They both are irrational. This is correct. Till the option is correct. Yeah, till this information is correct. The both pairs are irrational number. But the result is not irrational. They are asking that the result, the product should be rational number. Here the result is under root 10. And under root 10 itself is an irrational number. So this will not be the answer again. Now please come on option number C here. What option number C is saying? Okay, the option number C, under root 3. Under root 3 is perfectly irrational number. Yes, root 3 cannot be represented in the form of P by Q. Non-terminating, non-repeating decimal cannot be, exist in the form of P by Q. Okay, so this is irrational number, right? And the second option in the pair is under root 27. Under root 27. And under root 27 can also be written as 3 root 3. And 3 root 3 is also the format of irrational number. So both are irrational. This is clear. This is sure that both are irrational number. Under root 3 is irrational number. And root 3 is making this whole number as irrational number. So this is also irrational, this is also irrational. Let's do the product of these two numbers. So if I multiply these two numbers, under root 3 into 3 root 3, so what will be the result? 3 into 3. Wow, the result is 9. The result coming is 9. 9 implies that 9 can also be represented as 9 by 1. And that is the format of P by Q. Yes, this is the form of P by Q. This is the form of P by Q, where Q is not equals to 0 because Q is equals to 1 here. Q is equals to 1 here. So 9 by 1 is a rational number. These two numbers are irrational number. Their product is rational number. And what the question was asking, a pair of irrational numbers whose product is a rational number. So option number C is the correct answer. Option number C is the correct answer, because both the pairs are irrational number, but their product is coming as a rational number. So the option number C is correct answer. Hope you have understood. If you are still having any kind of problem, please put your problem in comment section and kindly share this video with your friends. Please do subscribe this channel and please follow us and please share with your friends as well. Okay, please come on next question. This question was asked in the year 2024. This question was also asked in the year 2024. Okay, so the next question is, if two positive integers P and Q can be expressed as P 18A square B to power 1 and Q is equals to 20 A cube B square, where A and B are prime numbers, then LCM will be, what will be the LCM? What will be the LCM? Guys, I am giving you a trick here to calculate the LCM and HCF here. By the way, we are going to talk about in depth whatever the next video is going to be uploaded in the channel. That will be one short video on real numbers. So we are going to talk about again, right? But here for this question, or I am giving you a short trick to find out the LCM and HCF. Let's say one question is here. If I ask you what will be the LCM and HCF of 16 and 80, what will be the LCM and HCF of 16 and 80? Okay, so LCM and HCF we are going to talk about of 16 and 80. By prime factorization method we are going to talk about, but I'll give you a trick here how we can easily find out the HCF and LCM of any two numbers. Okay, so factorize it first. So what will be the factorization? 2 into 2 into 2 into 2, that will be 2 to power 4, right? And for 80, what we can do here? For 80, what we can do? We can take LCM here. So by taking 2, 40 here, 2, 20 here, 2, 10 here, 2, 5 here, and 5, 1 here. Okay, so the factor will be 2 into 2 into 2 into 2 into 5, and it can also be written as 2 to power 4 into 5 to power 1. I am giving you a trick. I am giving you a short trick to find out the LCM and HCF of between two numbers. Okay, so look here, in 16 there are factor only 2. There is no any other number. But while we talk about, if we talk about 80, there are two factor here. 2 can also divide 80 and 5 can also divide 80, because 2 and 5 both are coming here. 5 is not here. So if 5 is not here, we can write 5 to power 0. Yeah, we can write 5 to power 0 because the power of any number is equals to 1. So no need to worry, right? We can write 5 to power 0. Now, 2 and 5 both are here, 2 and 5 both are here. The power are different, right? The power are different because the number are different, right? Now, I am giving you a short trick to find out LCM HCF. So how we can find LCM? LCM. So you know the definition of LCM. LCM is called least common multiple. Lowest common multiple. So there is a trick. If we talk about lowest common multiple, least common multiple, means you will take the opposite of this stuff. If I talk about lowest, so you are going to take highest power. This is the short trick. If I talk about lowest, so we will take the highest power here. So here in these two, what is the highest power of the factor? So 2 to power 4 is here and 2 to power 4 is here. So luckily both the power are same, so we can write it 2 to power 4. Now there is another factor 5 is here. Here 5, the power of 5 is 1, and here 5 is in the form of power 0. But I'm giving a trick. We are talking about lowest common multiple. For lowest, we will take the highest degree. So in 5 to power 0 and 5 to power 1, what will be the highest? 5 to power 1. So we are going to take 5 to power 1. For lowest common multiple, we will take highest. And for highest common factor, we will take lowest degree. Right? Lowest power. Right? So what will be the LCM? The LCM will be 16 into 5. That will be 80 answer. Okay? So this is the trick. If you want to find out the LCM of any two number, you make sure you are going to take the highest power, because we are talking about lowest. This is a trick. So what does it mean by this result? What this result is saying? This result is saying that 80 is the lowest common multiple. If you write the factor, if you write the multiple of 16, if you write the table of 16, and if you write the table of 80, 80 will be that number which will be common in these two. If you write the multiple of 16, what will be the multiple of 16? 16, 32, 80, and so on. And if you write the multiple of 80, what will be the result? 80, 160, 240, and so on. Which number is common in both? 80 is common in both. Look at the number. Yeah, this will be the LCM. There is no any other number which is common in both. Only 80 is common in both. So the 80 will be the LCM of these two numbers. The 80 will be the LCM of these two. Are you getting my point? Are you getting my point? So 80 is the LCM, right? Now please find out here the HCF. So what will be the HCF here? What will be the HCF? So for HCF, what we can do? Okay. Now please come on short trick of HCF. You know the definition of HCF, the form, the HCF, what HCF is? HCF means highest common factor. Highest common factor. And the trick to find out the HCF is, if you want to find out the HCF of any two between any two numbers, right? So there is highest term. But what we have to do? What we have to do? We have to take the lowest power. In lowest, we have taken the highest degree, highest power. But in HCF, we will take lowest power. So what will be the lowest power here? Look. 2 to power 4 and 2 to power 4. Which is common here? Which number is common here? Look, which number is common here? Here in these two. The factor 16, the prime factor of 16 is here, and the prime factor of here. And highest common factor, common, that number should be in both. So 2 to power 4 and 2 to power 4, in both. So 2 to power 4, luckily both the power are same, so no need to worry. 2 to power 4, what will be the result? The result will be 16. 16 is the HCF. Because the common, we must conclude common also here. The common is also present here. Common, that number should be in both. So what does it mean by this result 16? Highest common factor. Factor means this number can divide this, and this number can divide this also. Highest common factor means that number which can divide both. LCM means that number which can divide by these two numbers. Highest common factor is that result which can divide these two numbers. And the LCM is that result which can be divided by these two numbers. This is the difference between both. This is the difference, right? So this will be the result. So please come on this question here. So the question is, if two positive integers P and Q can be expressed as P, okay. So we have to find the LCM, okay, of these two numbers. So let's say factorize these two, P and Q. What will be the prime factorization? Factorization basically. So 18 a square and b to power 1. It can also be opened as 2 into 3 square into a square into b to power 1. Hope you understood. 3 square means 9, 9 2 is 18, right? And q is here, and q can be written as 20 a cube b square, and it can be written as 2 into 2 into 5. 2 to the 4, 2 to power 2, 4, 4, 5, 20, right? And into a cube into b square, right? Hope you understood. Hope you understood. And what the question is saying? Question is saying to find out the LCM. LCM. And I just given you the trick. For LCM, lowest common multiple, what we'll do? We'll take highest power. Yes, highest power. Now, one more thing. If you can observe here, 5 is here, but 5 is not here. We can write, no? We can put 5 to power 0 for your comfortability. Whenever you will already do so many questions, and you will in future, if you will go through a number of questions, you will be ultra pro. You don't need to write these here, right? But in initial phase, I'm just giving you a trick. If you feel confusing how the teachers are doing the question comfortably, I'm not able to do. So for this, I'm just giving you a trick. If 5 is here but 5 is not here, we can put 5 to power 0. If 3 is here but 3 is not in here, we can put here 3 to power 0. No need to worry about it. Right? So what question is saying? The question is saying to find out the LCM, least common multiple. And in least common multiple, least, so what will be the opposite? Highest, greater. The opposite of least is greater. So what will be the greater power of 2? Here 2 to power 1, here 2 to power. So what we will do? Greater. We will take greater. We will take greater. And here 3 to power 2 and here 3 to power 0. So which power will be taken? Which power will be taken? We are talking about LCM, so which power will be taken? The greater. Greater. So 3 square will be there. Here 5 to power 1, here 5 to power 0. Which power will be taken? 5 to power 1, because we are solving LCM. Right? We are solving LCM. And here a to power 2 and a to power 3. Which power will be taken? Again I am asking a to power 3, because we are calculating LCM here. Don't take tension. Don't feel fear. Don't get worried. I am here to solve your query. Okay, b to power 1, b to power 2. Which power will be taken? Simple. And solve it. The result will be in front of you. 2 to power 2, 4, 9, 4, 9 and 5, a3, b square. So what will be the result? 5, 4, 20, 29, 180, a to power 3, b2. Is there any option? Is there any option? 180, a3. This will be the answer. Hope you understood. Hope you understood. Hope you have understood. If you still having any problem, please put your problem in comment section. I am going to surely look into it, and I'll surely provide some alternative for that. Okay, so please come to the next question. This is important question. I have already marked important here in a look at the question. What question is saying first? Please read the question calmly. Read the question peacefully first. What question is saying? Please read the question. Okay. So in teachers workshop, the number of teachers teaching French, Hindi, English are 48, 80 and 144 respectively. Find the minimum number of rooms required if in each room the same number of teachers are seated and all of them are of the same subject. Wow. Okay. The question is asking, okay, so there is a workshop is going on and there are several teachers of different subjects. So the data is given as the teacher who is teaching French, the number of that teacher is 48, Hindi teacher 80 and the number of English teacher is 144 respectively. Find the minimum number of rooms. So the question is asking how many numbers will be required so that the teachers can be arranged in those rooms according to the same number of teachers, like the number of teachers should be same in the number. So in such question generally we need to find out the HCF, because they are asking ki what should be that number which can divide these three. So basically if the condition is like ki, then we are asking, the question is asking to calculate that number which can divide these three. So indirectly the question is asking to calculate the HCF simply. Okay, so here okay, what should be the equal number of teachers and how many number of rooms will be there, how many number of rooms will require there, number of rooms, minimum number of rooms required. So first of all we have to find out how many teachers will be there in one room exactly. Okay, so for that we have to find the HCF. Okay, so by using prime factorization method, by which method? By prime factorization method. By prime factorization method. This question is asked in CBSE 2024 recently. Okay, so by prime factorization method 48. Kindly write down the prime factorization of 48. What will be the factorization? 2 to power 4, 16 will be there, and 3 to power 1. Hopefully this is correct. 80, 2 to power 4, 16 and 5 to power 1. Hope it is correct. 144, that number will be 2 to power 4 16 and 3 to power 9, 16 9, that will be 144. Correct? What we are calculating here, what we are finding here, we are finding HCF, highest common factor. And what was the trick? I just told you few minutes ago, HCF, highest common factor. We are talking about highest. So what will take? Lowest and common. Which will be the common number? Only common number we can see here is 2 to power 4. There is no any other number which is common is these three. Only 2 to power 4 is common in these three, right? So we can write 2 to power 4, and 2 to power 4 is 16. The HCF is 16, means this is the number of teachers that will be arranged equally in so many rooms. I don't know how many rooms are there, because still we have to find out the number of rooms. This is the number of teachers who will stay in those rooms, the rooms which will be allotted. The number of teachers will be 16 in each rooms, but I don't know, I'm not sure what will be the number of rooms yet, right? So how we can find out the number of rooms? Okay, so for this is the number of teachers who will be staying in each room, in one room, right? So to find out the number of rooms required, number of rooms is required. How we can find this result? Number of rooms requires total number of teachers, total number of the teachers participated in the workshop, total number of the teachers divided by number of teachers in each room, number of teachers in each room, So what is the total number of teachers? That is 48, adding with 80 plus 144 and divided by 16. Okay, so what will be the result? The result will be 4, 8, 12, 12, 2, carry 1, 5, 5, 8, 13, 13, 4, 17, 17, 7, 1, carry 1, 272 and divided by 16. So by dividing by 16, 16, 1, 16, 16, 16, 1, 16, 1, 1, 1, 17, 1, 7. So number of rooms required is 17. Answer. This is the answer here. Okay. So the result is, we can write here, number of rooms required. Number of rooms required is 17. So hope you have understood. So in each room the number of teacher will be 16, and how many rooms will be required? 17. Because when you will multiply 16 by 17, you will be getting the number of teachers equal to the sum of these numbers. So 16 and 17, that is equals to 272, and the total number of teachers attending in the workshop is equals to 272. The addition of these two numbers is 272. Hope you understood. Hope you have understood. Hope you have understood. So let's come on the next question. If HCF of 65 and 117 is expressible in the form of 65 n minus 117, then find the value of n. This is very easy question, I can say, because the HCF, the two numbers are already given, and their HCF is not given in a number, particular number. The HCF is given in a format. There is a format, and we have to find out the value of n here. So firstly, we have to find out the HCF of these two numbers, 65 and 117, by that ordinary method, which is prime factorization method. Okay, our friend. So find out the HCF by using what? Prime factorization method. prime factorization method. By using prime factorization method. Okay, so find out the prime factor of 65. That is simply 5 into 13. Okay, another number is 117, and the factor of 117 is equals to 3 square into 9. Oh, sorry. Three square into, oh my god, 3 square into, oh my god, sorry for the issue you are facing, because there is technical problem here. There is a technical problem. Okay, so 3 square into 9, that is equals to 170. So the factor of 65 is 5 into 13, and the factor of 117 is equals to 3 square into 13. Okay, 9, 13, 9, 3 square is equals to 9, and when multiply 9 by 13, that will be 117, right? Okay, so what will be the highest common factor? Common factor. The number should be in both. The factor should be in both. Common factor. So which number we can see here is common? 13 here. 5 is here, but 5 is not here. 3 is here, but 3 is not here. But what HCF is saying? HCF is saying highest common factor, right? Common. So 13 will be there. So the HCF is 13. HCF is 13. Okay. But here in this question, the result of these two numbers, the HCF is these two numbers is not given as 13. That is given is the form of equation here. There is an equation. So we can equate equation equal to this. So according to question AQ, we can write 65n minus 117, that is equals to 13. Because this format is what? This format is the HCF. This format is HCF here. So we can equate here 65n is equals to 13 plus 117. So 65n is equals to 130. You can add 117 into 13, that will be 130. So n will be equals to 130 by 65, and that will be 2. So the value of n is equals to 2. Hope you understood. Hope you have understood. Hope there is nothing challenging in this question. There is nothing to worry in this question. Okay, so please come on next question. So the next question is, this question has been asked in the year 2023, and what the question is saying, find the least number which when divided by 12, okay, which when divided by 12, 16 and 24, leaves the remainder 7 in each case. This is an interesting question, guys. Kindly focus and be very attentive to this question. This question you should understand, because such question generally frequently asked in your school, in your board examination or whatever. So, okay, so find the least number which when divided by 12, 16, 24 leaves the remainder 7 in each case. How we can tackle this question, how we can solve this question. See, look at the question, just go through in depth in this question. There is a number, find the least number. I don't know the number. I'm not sure what exactly is that number. Find the least number which when divided by this, this and this, and the remainder coming is 7. So keep one thing in your mind, that there is a number and that number is dividing by these 3. It implies that that number will be greater than these 3, because they are dividing that number. So the result will be greater from these number. So this indicates that we are not going to find HCF anymore. We are going to calculate LCM, right? Because they are dividing to that number. Any number is not dividing these. If any number is dividing these number, so that will be the factor. So we can conclude HCF. But here in this question, these numbers 12, 16 and 24 they are dividing to any other number. So means it indicates that, it proves that that number will be greater from these numbers. So the result will be LCM, because LCM always comes greater and HCF always comes smaller or equal. We can conclude a smaller or equal, but HCF cannot be greater than number. LCM can be greater than the number. So here these three numbers are dividing those numbers. I don't know, I'm not sure. So what we have to do, we have to find the LCM of these three. And if remainder is 7 is coming, so what we have to do to eliminate the remainder, at the end we can add the 7. Whatever the result will come, we can add the 7 to that number. So that will be your answer. So what we have to do here, we have to find out the LCM by using prime factorization. Prime factorization method. What we are going to do, what we are going to do, LCM, we are finding LCM here. Why LCM? I just already told you, because these three numbers are dividing any other number. So it implies that that number will be greater from these three, right? So we have to find out the LCM, right? So write down the prime factorization of 12, that will be 2 square into 3. Hope it is correct. 16, what will be 2 to power 4? For 24, what will be the result? Hope it is correct. Kindly check it once. Kindly check it once. 2 to power 3 into 3 to power 1. Okay, so these are the numbers. And what we are finding? We are finding LCM. And I have given you the trick for LCM. LCM means lowest common multiple, whatever you can say. So for lowest, what we will take? Highest degree. Opposite. So highest degree is this. What is the highest degree? The highest degree of 2 is 2. So the LCM will be 2 to power 4 into, so here is 3, but 3 is not here. We can put 3 to power 0. If 3 is not here, we can put 3 to power 0. And what will be the highest in these 3? 3 to power 1 is highest. So we can write 3 to power 1 here. So what is the LCM? The LCM is 48. And what the remainder is coming here? The remainder is 7 here. So the number is, so the number will be what? The LCM, whatever the LCM came, plus 7. Whatever the LCM came, plus 7. The LCM is 48. And 7 is coming as remainder. So the result is 55. So 55 is that number to which these are dividing and the remainder is coming as 7. You can prove it. Divide 55 by 12. So when we will divide 55 by 12, what remainder is coming? Wow, remainder 7 is coming. Means answer is correct. Again, divide 55 by 16. Okay, so what remainder is coming? Wow, again 7 is coming. Correct. Divide 55 again by 24. 24 is dividing 55. 24 to just 48 and remainder, oh, again remainder is 7. Means 55 is that number to which these numbers are dividing and the remainder is coming as 7 here. So this is a bit interesting question. Okay, hope you have understood. Okay, now please come on this question. This is important for boards. As I have already marked here, important for boards 2026. Okay, what the question is saying, please read it calmly. Please read the question peacefully. Kindly focus the question, what the question is saying. Okay, so two positive numbers have their HCF as 12 and their product as 6336. The number of pairs possible for the numbers is what? Okay, this question is a bit, good question I can say. So how I can do? So there are two positive numbers and their HCF as 12. I am not sure what exactly the numbers. The numbers are unknown. The numbers are unknown. I don't know the numbers. But their products are given. Their products are given. And we have to find the number of pairs. How many pairs can be there of that number. So let's first find out the number. What exactly the number is. What exactly the numbers are. Okay. So if I can conclude, I am not sure what exactly the number, but that number is dividing by 12 because 12 is the HCF, and I have already told you HCF is the highest common factor. Highest common factor is that number which can comfortably divide the number and the remainder will be 0. So if in this question HCF is 12, means 12 is comfortably dividing the numbers which is unknown, yet that number is dividing by 12. So the number we can conclude, if 12 is the HCF, so the numbers can be taken as, I can write here 12A, 12B, because both numbers are dividing by 12 because 12 is the HCF. If I divide 12A by 12, it is comfortably cancelling. If I divide 12B and by 12, it is comfortably dividing. So we can conclude, we can assume the number will be 12A and 12B. What exactly A and B I don't know, but we can take as 12A and 12B because 12 is the HCF of that numbers. So the numbers can be taken as 12A and 12B. Now follow the question. Now follow the information provided in the question. The next information is their product is 6336. So if you have assumed the numbers 12A and 12B here, their product will be 6336. So we can write according to question AQ, according to question here, 12A into 12B can be written as 6336. Yeah, the question is saying their product is 6336. So A into B can be written as 6336 divided by 144. Is it clear? Because the product of 12 and 12, that is 144, and on shifting 144 here, that will be in dividing form. So divide by 144, 4, 4, 16, 4, 4, 16, the result will be 44. So the product of A in B is 44. One information we have found here is, it is clear that the product of AB is 44. Now it is clear. We have concluded, we have solved the product of AB is equals to 44. Whatever A and B I don't know, their product is 44. So we can assume, we can let, if the product of AB is 44, so A comma B we can assume as A comma B, I am writing here this side because there is no more space. So I am writing here, if the product of A and B is 44, so we can let like A comma B will be the first factor. The first pair can be 1, 4, 4. The second bracket can be 2, 22. A can be 2 and B can be 22. And the third bracket can be of 4 and 11. I am talking about just A and B. We are moving towards the number. What exactly will be the number? The number is not sure yet. The number is not sure yet. We are just operating here A and B. We are talking about still A and B only. So if the product of A and B is 44, the bracket will be this. These can be bracket. So look here, the A is 1 and B is 44. Here the A is 2 and the B can be 22. Here the A can be 4 and B can be 11. But here A and B, here in this bracket A and B, 2 and 22 is here. 2 and 22 is not, look, 2 and 22. 2, what will be the factor of 2? 2 in 1. And about 22, what will be the factor? 2 into 11 into 1. Are they prime numbers? Are they prime numbers? Are they prime numbers? They are not prime numbers. Because the factors are 11 also here. If the factors will be number and itself, we can say. So we cannot take this pair. So this pair will be eliminated. Only these two pairs will be there. Only these two pairs will be there. Right? 144 and 411. So what will be the number? So the numbers, why we are eliminating these two? Why? Can you conclude? Because 2 and 22 here. Here 1 and 44. Here 2 and 20. They are not co-prime. They are co-prime. They are co-prime. They are co-prime. They are not co-prime. That is the reason I am eliminating this bracket here. It cannot be, this is not fitting here. That is why I am just ignoring and eliminating this bracket here. So the number was, what the number we taken? That was 12A and 12B. So taking the first bracket, what will be the number? The number will be 12A will be 12 into 1. So the number will be 12. 12B, 12 into what? 44. The number will be 528. So the first bracket will be 12, 528. Okay. The next, this is the first. And what will be the second? Second bracket is 12A and the A is 4, 48, and 12B, 12 into B, B is what? 11. And what will be the number? 11, 22, 20, 11, 12, 12, 132. 132. So the pair will be 48, 132. So how many pairs are possible here? How many pairs are possible? Only 2 pairs are possible. So in this question is interesting, I can say. Yeah. So in this question, the number of pairs were asking, the number of pairs possible for the number. So how many pairs can be possible? 2 pairs. 2 pairs are possible. Okay. How many pairs are possible? 2 pairs are possible. So how many pairs are possible? 2 pairs are possible. 12, 528 and 48, 132. So they were the important question, and that has already been asked in board examination, previous year question. I'm going to provide you, the next video will be one short video of real numbers, and that video will be so much profitable for you. So I'm requesting you everyone, kindly follow us, follow our instruction, and keep watching the videos and keep following the instruction we are providing to you for your benefit, for your performance, to enhance your skill. So we are here for your complete academic solution, no need to worry. And again, lastly, I am requesting kindly follow the channel and please subscribe the channel Deeksha Vedantu, because we believe in quality education and we are continuously providing the quality education to you all, not only in maths, in every subject. Thank you for watching this video. Thank you so much. And lastly, for you, thank you. Keep smiling, stay focused, and be optimistic. Thank you so much for watching. Thank you.